Evaluating an electrical service contracting business in the Virginia Beach, Norfolk area requires understanding typical labor rates and new construction pricing. For a master electrician, the average labor rate for service calls ranges from $100 to $140 per hour. For an electrician mechanic, the hourly rate typically falls between $80 and $120. When pricing new residential construction to code, a general range is $1 to $1.50 per square foot. However, several additional factors can significantly influence these figures. Firstly, the specific location within Virginia Beach or Norfolk can lead to variations in both labor rates and construction costs. Secondly, the experience and reputation of the contracting business itself will impact its pricing structure. A well-established firm with a strong track record may command higher rates. Thirdly, it is crucial to factor in overhead costs. These include expenses such as insurance, materials, marketing, vehicle maintenance, and administrative salaries. Failing to account for these overheads will result in inaccurate pricing and potentially unprofitable projects. Fourthly, the size and scope of the project play a vital role. Larger, more complex projects will generally have different pricing models than smaller, straightforward jobs. For example, a whole house rewire will likely be priced differently per square foot compared to installing a few new outlets. To obtain more precise estimates for a specific area and project, it is highly recommended to consult with local electricians and contractors. They possess first-hand knowledge of the current market conditions and can provide tailored quotes based on the unique characteristics of the work involved. These local professionals can offer insights into prevailing wage rates, material costs, and permitting fees, all of which contribute to the overall project expense. Understanding electrical codes is essential for accurate pricing. Code compliance ensures safety and functionality, directly impacting the cost of materials and labor. For example, the National Electrical Code, or NEC, outlines minimum requirements for wiring methods, overcurrent protection, grounding, and other critical aspects of electrical installations. These codes dictate the types of materials that must be used, such as specific wire gauges, conduit types, and box sizes. They also specify how these materials must be installed to meet safety standards. Consider the impact of ampacity. The current carrying capacity of a conductor is paramount. The NEC provides tables, such as Table 310.16, which specify the allowable ampacities for various conductors based on their size, insulation type, and ambient temperature. Selecting the correct wire gauge based on the expected load is critical to prevent overheating and potential fire hazards. For instance, a 15-amp circuit typically requires 14-gauge copper wire, while a 20-amp circuit generally needs 12-gauge copper wire. However, specific applications may necessitate larger wire sizes due to voltage drop considerations or other factors. Overcurrent protection devices, such as circuit breakers and fuses, safeguard electrical circuits from overloads and short circuits. The NEC mandates the proper selection and installation of these devices to protect wiring and equipment. Circuit breakers are typically rated in amps and are designed to trip or interrupt the flow of current when the current exceeds the breaker's rating. For example, a 15-amp circuit breaker is used to protect a 15-amp circuit, preventing it from being overloaded. Grounding is another fundamental aspect of electrical safety. A properly grounded electrical system provides a low impedance path for fault current to return to the source, allowing overcurrent protection devices to quickly trip and clear the fault. The NEC specifies grounding requirements for various types of equipment and systems, ensuring that all conductive surfaces are properly grounded to minimize the risk of electric shock. Ground fault circuit interrupters, or GFCIs, are life-saving devices that protect against electrical shock by monitoring the current flowing in a circuit. If a ground fault is detected, the GFCI will trip quickly, interrupting the power supply. The NEC requires GFCI protection in areas where there is a high risk of exposure to moisture, such as bathrooms, kitchens, and outdoor locations. Arc fault circuit interrupters, or RSIs, provide protection against arc faults, which are dangerous electrical conditions that can lead to fires. ASIs are designed to detect the unique characteristics of arc faults and trip the circuit, preventing the arc from igniting nearby materials. The NEC requires ASI protection in many areas of the home, particularly in bedrooms and living areas. Wiring methods, such as the use of conduit, cable, and other wiring systems, are also governed by the NEC. The NEC specifies the types of wiring methods that are permitted in different locations and applications, ensuring that wiring is properly protected from physical damage and environmental factors. Conduit, such as rigid metal conduit, electrical metallic tubing, and flexible metal conduit, provides a robust and protective enclosure for electrical wiring. Cable, such as non-metallic sheath cable, armored cable, and underground feeder cable, is commonly used for residential wiring applications. Electrical boxes are used to enclose and protect electrical connections. The NEC specifies the types of electrical boxes that must be used in different locations and applications, ensuring that connections are properly made and protected. Box fill calculations are used to determine the maximum number of conductors that can be installed in an electrical box. The NEC provides guidelines for calculating box fill to prevent overcrowding and ensure that connections are properly made. Understanding voltage drop is also crucial for efficient and safe electrical installations. Voltage drop occurs when the voltage at the end of a circuit is lower than the voltage at the source due to the resistance of the conductors. Excessive voltage drop can cause equipment to malfunction and can also lead to overheating of conductors. The NEC provides guidelines for calculating voltage drop and recommends that voltage drop be limited to a certain percentage of the source voltage. For example, the NEC recommends that voltage drop in branch circuits should not exceed 3% and voltage drop in feeders should not exceed 5%. Lighting requirements are also addressed in the NEC. The NEC specifies the minimum lighting levels that must be provided in different areas of a building, ensuring that occupants have adequate illumination for their tasks. The NEC also addresses energy efficiency requirements for lighting, encouraging the use of energy-efficient lighting technologies. Appliance circuits are dedicated circuits that serve specific appliances, such as refrigerators, washing machines, and dryers. The NEC specifies the requirements for appliance circuits, ensuring that these appliances have adequate power and are properly protected. Electric vehicle charging equipment is becoming increasingly common, and the NEC addresses the requirements for installing electric vehicle charging stations. The NEC specifies the wiring methods, overcurrent protection, and grounding requirements for electric vehicle charging equipment, ensuring that these stations are installed safely and in accordance with code. Renewable energy systems, such as solar photovoltaic systems and wind turbine systems, are becoming more popular. The NEC addresses the requirements for installing renewable energy systems, ensuring that these systems are integrated safely and reliably into the electrical grid. The NEC also provides guidance on inspecting electrical installations to ensure that they comply with code requirements. Electrical inspections are typically performed by qualified electrical inspectors who are familiar with the NEC and local electrical codes. During an inspection, the inspector will verify that wiring methods, overcurrent protection, grounding, and other aspects of the electrical installation are in compliance with code. Deficiencies that are identified during an inspection must be corrected before the installation can be approved. Adhering to these codes minimizes risks and ensures the reliability of electrical systems. This in turn affects the pricing of electrical work. For residential construction, remember to factor in the cost of permits, inspections, and other regulatory requirements. These costs can vary depending on the municipality and the scope of the project. In addition to the direct costs of materials and labor, it is essential to consider indirect costs such as project management, supervision, and warranty work. These costs can add up significantly and should be factored into the overall project budget. To obtain a comprehensive understanding of electrical service contracting costs in the Virginia Beach, Norfolk area, it is advisable to network with local contractors, attend industry events, and subscribe to relevant trade publications. This will provide access to valuable information and insights into the current market trends and pricing strategies. Understanding the nuances of electrical contracting costs is essential for making informed investment decisions. By carefully considering labor rates, construction costs, overhead expenses, and code compliance, you can develop a realistic assessment of the business's financial potential.